Hey guys, Mr. King here. Today we're going to be talking about converting in the metric system. I'm a little annoyed because I just recorded this video and it's a kind of long video, but it disappeared. I don't know what happened. It didn't record correctly or something. But anyways, I've got here, this is a new microphone, so I know it's a little quiet. I don't know why. I was trying to get it to be louder, but I couldn't. So hopefully I'm talking loud enough that you can hear it. You may have to turn up the volume, but sorry if it's obnoxious. All right, well, today we're going to be looking at this PowerPoint, which you should have access to. This PowerPoint here, you should have access to it. We're going to be talking about the metric system. So you probably are familiar with the metric system in some degree because you should have talked about it in the past. But this is the metric system is the system units that we use in science for various reasons that we'll discuss in a minute. Now, normally I would have you all write these down in a notebook. Obviously, you know, things are a little different right now. You might not be using a notebook, right? You might just be taking a screenshot. You might be saving like a bookmark or whatever, but you need to have this readily available to you because we're going to be referencing this quite a bit over the next couple lessons. Now, I'll warn you, I'm a little nervous about this concept because dimensional analysis, because I think it's kind of hard to teach. It's easier to teach in person on paper. So I'm going to do my best to explain it, but as always, please ask questions if you have them. Really, this may not seem like a big deal, but it's actually a very useful skill. In particular, next year for chemistry, you're going to be using it quite a bit. If you go on to college and you have to take physics or chemistry in college, which a lot of people do, this will be extremely useful then as well. So this is really a skill that you can take on past this class, and it's just a problem-solving skill in general. Okay, so like I said, you can write these down if you want. You can take a screenshot, it's up to you. There's the first one. These are all the prefixes that are smaller than the bases. So notice you've got these blank spaces. The blank space stands for the base unit. So in the metric system, there are many different base units that could go there. Liters, meters, seconds, farads, watts, amps. I mean, there's so many different of these base units that can go in those blanks. Now we're going to leave them blank because we really want to focus on the prefixes. These are the prefixes that are larger than the base unit, right? So you see kilo, mega, giga. We especially think of that like kilometer, bytes like megabytes and gigabytes, and of course, this is just a portion of the metric prefixes. There are many more. These are the most commonly used, but you probably have already heard of terabytes when you get into data. So that's what's next after giga is tera, and there are more beyond that. They get really strange. You can look them up if you want to. They're like yocto and exa and some really strange ones. So again, make sure you have this available. I wanted to take a brief discussion of the pros and cons of the metric system. The fact is the metric system is used almost all over the world, and there's a reason for that, right? The reason why it's used, there's several reasons, and there's several pros for the metric system. The first one, a pro of the metric system, is that it is used all over the world. All but like 3 countries use the metric system. America is one of them, right? We use what's called the imperial or the English system of units, like feet, inches, yards, those sort of things, pounds. That's what we use, but we are the exception. Pretty much the rest of the world uses metric system. So that's a pro already. If you go to a different country and you're familiar with the metric system, you'll already know kind of how to, estimate different amounts. Another pro, probably the biggest one in my opinion, is that the metric system is based on powers of 10. If I ask you right now, how many feet are in a mile? Do you know the answer? It's 5,280. That's a strange number. And so then if I said, okay, how many feet are in 5 miles? Well, you'd have to take 5 times 5,280. And if you don't have a calculator, you can do it, but it's not easy. It's quite difficult. The metric equivalent of that would be, let's say I have a kilometer. And I tell you there are 1,000 meters in a kilometer. I say, how many meters are in 5 kilometers? Well, you already know the answer. It's 5,000 meters. We did that. It's almost without any effort at all, because multiplying and dividing by powers of 10 is very easy, as we saw yesterday in our assignments. One other pro is that you're able to convert in units that you don't know, right? There's a unit, I think it's for electrical impedance. maybe. It's called a farad, right? And or a capacitance. I think it's an electrical capacitance. So you may not know what a farad is. I don't know what a farad is apparently, but I know that even if I don't know what a farad is, I know that there are 100 farads there's 100 centifarads in 1 farad, and I know that there's 1,000 farads in 1 kilofarad. Even without knowing the unit, that's not the same in our system, right? If you don't know how many inches are in a yard, then you don't know how many yards or how many inches are on a football field, right? You won't know that. The only cons I can think of, number one would be for us, we're not familiar with the system, right? So like if I ask you to make an estimate of someone's height in inches and feet, you probably can do that. But if I said make their estimate in centimeters, we'd probably be pretty far off because we're not familiar with it. And the other con is that sometimes the base unit is not very useful, right? Think about data, right? The base unit of data storage is a byte, but I mean, we don't talk about bytes, all right? Nothing is a byte, right? We're talking about usually megabytes, at least kilobytes maybe, but gigabytes and so on. So that's a little discussion about pros and cons of the metric system. There's a video there, Is America Actually Metric? You can check it out. I like it. I think it's an interesting video, but you're not required to watch it. Multiplying fractions without a calculator. I'm going to check my recording, make sure, because I've got to switch over anyways. Okay, should still be recording. Now you may wonder, why am I talking about multiplying fractions? Because when we use dimensional analysis, we will be setting up fractions and basically using them to figure out our answer. Let me show you what I mean here. So a lot of times people forget or are not sure how to multiply fractions, and it's actually quite simple. So you see here I've set this up. All you have to do to multiply a fraction is just multiply across the top and multiply across the bottom. 2 times 5 is 10. 3 times 7 is 21. 10 over 21 is the answer. It's that easy. I think people maybe get it confused with adding and subtracting fractions, which is a lot harder. But yeah, multiplying is actually pretty straightforward. I'm going to show you another example here, the second one. 3/5 times 4/9. Now this one, something interesting happens, right? On top we have 12. 3 times 4 is 12. On the bottom, 5 times 9 is 45. For those of you curious, I did just have to use my fingers to figure that out. That's okay. Now you may recognize that 12 and 45 both are multiples of 3. And if you know that, then you can simplify, right? Because we divide both top and bottom by 3. 12 divided by 3 is 4. 45 divided by 3 is 15. There's an announcement. I can't control it.
Ask if any of you have students here, any of your
kids
are with you here in the building and would like to have breakfast or lunch.
Okay, I meant to show you this up here. Please make your way to the
cafeteria between 10:30 and 10:45.
It's almost an hour.
That's their downtime. That they'll be
still talking about
it. Our students here in the building and.
Okay, well, I'm going to talk over my guys. What I meant to say here was that you could also recognize that 3 and 9 are both multiples of 3. So really, when we have the fraction, a fraction is just division. It just means divide by. So here we have, this is the same as 3 times 4 divided by 5 divided by 9. If you did that in your calculator, 3 times 4 divided by 5 divided by 9, you would get the same answer. Well, think about this for a second. 9, I could rewrite 9 as 3 times 3. So really I'm saying 3 times 4 divided by 5 divided by 3 divided by 3. Well, hold on. Why would I take and multiply by 3 and then later divide by 3? I wouldn't, right? That they are inverse operations. It doesn't make sense. So if I write it like that, I could actually cancel. If I have the same thing top and bottom, I can cancel it. So this is really, on top is just 4. On the bottom, 5 times 3 is 15, and you get obviously same answer. So either way works, but I'm just trying to show that if you have the same thing top and bottom, they cancel. Like right here, 3/5 times 5 over 4. Notice I have a 5 in the top and bottom. Well, I can just get rid of those. Because once again, that's 3 times 5 divided by 5 divided by 4. 3 times 5 divided by 5, that's the same thing as like plus 10, minus 10. They're inverse operations, so they cancel each other. And the answer is just going to be 3 over 4. Okay, now why did I show you that? Because we are going to be sort of dividing fractions in just a moment with units. And that's the dimensional analysis. That's what it means. So this is called the dimensional analysis script. Now, again, I would have you write this down. You can write this down if you'd like. You can just sort of take a screenshot if you want. I don't know, but you need to have this around because you're going to refer to this quite a lot. And this may not make a lot of sense yet, but you're going to see the process in just a moment, and it will hopefully clear it up just a little bit. All right, I'm moving on. Hopefully you got that. So first problem. It says, without a calculator, convert 210 meters to kilometers. So I'm going to show you how to do that. And now I want to emphasize that this may seem strange at first, but as you get more familiar with this, it's going to work out. It should work out pretty well. So let me show you first. Let's convert 210 meters to kilometers. So the first step, as you can see in your script, is you take the original number in unit and put it in scientific notation. So we talked about this yesterday, or well, I guess 2 days ago. So 210, obviously the decimal point is right there. If I want to make this into a scientific notation, I need to move that 1 2 times to get a number that's between 1 and 10, which is 2.1. So in scientific notation, that's 2.1 times 10 to the second meters. Again, if you're struggling with scientific notation, please ask me for help during one of our, scheduled class times. Again, I don't expect you to be at those Google Meets, as they're on the daily schedule, unless you have questions, and I will be there. So if you have questions, that's a good time to come and ask. All right, so we're going to take this, and again, the scriptures tells us take the given unit, put in scientific notation, put it over 1. Then we're going to make a time sign, division sign. So you can see we're setting up a fraction. We're setting up a conversion factor. Now this is where you need to reference those notes because we have meters, but we want kilometers. So we need to ask the question, do we know how to convert between meters and kilometers? And hopefully the answer is yes, because we have, I'm going to go back here, this conversion factor right here. It says 10 to the third blank equals 1 kilo blank. Of course, the blank is in this time is meter, right? That's our base unit. So really this says 10 to the third meters equals 1 kilometer. And I'm going to write that down here just so we have its reference. Let's see if I can write it in red. So it said 10 to the third meters equals 1 kilometer. This is a conversion factor. We're saying these two things are equal to each other. So we want to write this conversion factor down here. But how do we know what goes on top and what goes on bottom? Well, this is where that dimensional analysis and that multiplying fractions comes into play. Because I do not want meters. I want kilometers. I want to get rid of the meter. So in dimensional analysis, we treat these units, like meter and kilometer, we treat them like numbers. So if I want to get rid of meter, where would it have to go over here so that it would cancel out? And of course, it would have to be on the bottom. If it was on top, it would be meters times meters would be meters squared. We want meters down here. So because I know meters goes down here, now I know what number goes down here, right? Because I'm just recreating this. So 10 to the third goes beside meter. The other side is going to be 1 kilometer. So now I've set it up. Look what cancels. Meters cancel. You can cancel the ones if you want to. No problems there. So let's see what I get when I multiply this. So multiply, do the math here. On top is just 2.1 times 10 to the second. Don't forget kilometers. Even we just did 2.1 times 10 to the second times kilometer. On the bottom is just the number 10 to the third. Well, we can simplify this, right? This is what we talked about yesterday. We know 10 to the second divided by 10 to the third. When we divide powers of 10, we simply subtract the exponents. So this is 2 minus 3. That's 2.1 times 10 to the negative first. And that's our answer right there. So this is, and I know this is different. I know this is kind of strange. And this is something that we're going to work on. right? So I know that was a little weird. You can go back and watch this again. That's something you may have to do, right? That's something that, you know, you may have to do when you talk about distance learning, virtual learning, is you kind of have to make sure that you are, there we go, sorry, I was on the wrong one. You have to make sure that you know kind of how to regulate your own, yourself. So I know this is strange. We're going to practice with it tomorrow. There's no specific assignment today beyond watching this video, taking notes, again, maybe rewatching it if you need to. This is, like I said, an important skill, one that you will use not only today, but in the future as well. So, I think that's where I'm going to end the video. Once again, I want to remind you that I'm available depending on, I'm following the daily schedule. I don't expect you to be at the Google Class meetings, the Google Meets, unless you need help. But if you do need help, please come. And I'll be there, depending on what day you're watching this, today or at least again, according to the schedule. That's when I'll be available. I'll have the Google Meet open so you can just hop in. You want me to do problems for you, I'll do problems for you. That's fine. We can work on problems together. But again, this is something that I hope you do take seriously. And I know that you can easily just type this in. You're on a computer. I know you can type in and find the answer in just 5 seconds. I don't want you to do that though. I want you to try to do it on your own. I want you to struggle a little bit. And again, it's a good struggle because this is a good problem solving skill. It has applications in many places. So I know it's strange, bear with me. Again, there's no official assignment today, just watching this video, taking notes, that's your assignment. And then tomorrow we'll do more examples. I'll go through 2 or 3 examples with you, and then I'll have you do a few on your own as well. Okay, please let me know if you have questions. See ya.